the vast silence of space. Some parts of space could be stretching faster than others, tearing invisible rifts into space-time itself. Adam Rees, the lead researcher on this crisis, said it plainly. With errors ruled out, the only conclusion left is that we may have misunderstood the universe at its core. And while scientists call this exciting, the truth feels closer to terrifying. If our understanding of expansion is wrong, then our estimates of the universe's age, its true size, and even its ultimate fate may all be flawed. The James Webb Telescope has brought unprecedented precision, leaving no room for doubt. Hubble and Webb both confirm the same impossible contradiction. The cosmos is expanding, but in a way that defies the very laws of physics. This discovery alone would be enough to rewrite textbooks, but Webb was only beginning. As its gaze stretched further into the deep, it uncovered not just contradictions, but objects and phenomena that shouldn't exist at all. Strange anomalies began to appear, suggesting a universe far stranger and more dangerous than we had ever imagined. The crisis of expansion was only the first step in unraveling the cosmos. What came next seemed almost simple by comparison. 6 colossal galaxies hiding in the dawn of time. When Webb directed its infrared gaze toward what should have been an empty patch of sky near the Big Dipper, scientists expected to see small, young galaxies, fragile structures barely beginning to form in the universe's first billion years. Instead, they found giants. 6 fully mature galaxies, each with star counts rivaling our own Milky Way, existed when the universe was only 3% of its present age. It's like planting an acorn and watching a towering oak tree appear in just 3 months. These galaxies should have taken billions of years to form, yet they stood in the infancy of the cosmos as complete star systems. Gravity should not have had enough time to gather the gas and dust needed for such colossal creation, and nuclear fusion should not have ignited on such a massive scale so quickly. calling them universe breakers, because their very existence threatens to dismantle our current understanding of how structures in the cosmos form. According to every simulation and model, matter in the early universe should have clumped together slowly, gradually merging smaller objects into larger ones over billions of years. Yet these 6 galaxies defy that expectation, suggesting the early universe was capable of complexity and organization far beyond what cosmologists had ever envisioned. This points to 2 disturbing possibilities. Either there is an unknown mechanism that allows galaxies to form and grow at lightning speed, or our deepest assumptions about cosmic evolution are disastrously wrong. The discovery also raises unsettling questions about dark matter's role in shaping the early universe. If such galaxies were able to bulk up so quickly, it means dark matter was pulling in gas and dust at rates far exceeding predictions. The hidden scaffolding of the universe may be more chaotic and violent than we imagined. Astronomer Joel Leger summed up the situation bluntly. We looked into the very early universe for the first time and uncovered something so unexpected that it poses real problems for science. Yet even greater mysteries awaited. To confirm whether these were truly galaxies, Webb's spectrograph would be needed, and those follow-up observations revealed something even more shocking. A cosmic monster drifting through space alone. Webb uncovered a supermassive black hole weighing as much as 50 million suns, wandering the young universe without a galaxy to call home. This was an object that defied every expectation. Normally, black holes of such scale anchor themselves at the hearts of galaxies, surrounded by swirling stars, dust, and gas. They grow in tandem with their hosts across billions of years. But this one was naked, drifting without a galactic companion, compressing its unfathomable mass into a space smaller than our solar system. To put this in perspective, if Earth were the size of a marble, this black hole, though invisible, would contain the mass of hundreds of billions of suns. The true horror lies in its timing. This rogue object existed only 600 million years after the Big Bang, far earlier than standard theories of black hole growth allow. According to conventional science, black holes form from the collapse of massive stars, which means first waiting for those stars to be born, to live, and to die in spectacular explosions. That process should take far longer than the universe had existed at that point. Roberto Maiolino, the Cambridge astrophysicist who helped identify this black hole, admitted it was completely off the scale. Its existence undermines every current model of black hole formation and growth in the early cosmos. Scientists now struggle to explain it, with 3 competing theories, and each one more unsettling than the last. The first explanation scientists have offered is that some black holes may form directly from the collapse of gigantic gas clouds, skipping the stage of star formation entirely. A second idea suggests that medium-sized black holes somehow consumed matter at rates far beyond what physics should allow, ballooning into giants far faster than expected. The third possibility is the most unsettling of all, that QSON is a primordial black hole, created in the first violent moments after the Big Bang, when fluctuations in space and time collapsed into gravity wells. If this is true, then QSON has been drifting unseen for nearly 13 billion years, waiting in the dark until the first stars and galaxies revealed its presence. And QSON is not alone. Webb has spotted hundreds of similar crimson points scattered through the infant universe, each one a potential black hole blazing with the light of shredded matter spiraling into its grip. The existence of these solitary monsters suggests the early cosmos was far more chaotic than the smooth, gradual growth cosmologists had long assumed. Instead of structures slowly coalescing, we may be staring at scars from ancient catastrophes that forged immense black holes before the very first stars were born. If QSON truly is primordial, then it represents something more ancient and alien than any galaxy or star, a relic from the universe's birth itself. And it is not the only impossibility Webb has found. Black holes that appear older than the first stars are lighting up the cosmos, hinting that they have been here since the dawn of creation. For decades, scientists assumed supermassive black holes formed only after massive stars collapsed at the end of their short lives, a process requiring hundreds of millions of years. Stars would first condense from clouds of gas, live their brilliant but fleeting lives, and then explode in supernovas, leaving behind dense remnants. Yet Webb has detected evidence of supermassive black holes already existing just 400 million years after the Big Bang, far too early for the standard timeline to work. Andrea Ferrara and his team at the Scuola Normale Superiore in Pisa proposed a radical solution. What if black holes, not stars, were the very first sources of light in the cosmos? What if primordial black holes had been born in the universe's first seconds, long before galaxies, quietly waiting in the dark? Unlike stellar black holes, these would have emerged directly from extreme density fluctuations in the primordial soup of energy and matter that filled the cosmos less than 5 seconds after the Big Bang. Imagine the newborn universe as a violently bubbling cauldron. In some regions, matter became so dense that it collapsed straight into black holes, never passing through the phase of star formation. Webb's data lends weight to this bizarre scenario. Many of the luminous points in the early universe appear compact, like pinpricks, instead of spread out like galaxies of stars, suggesting they are powered by black holes devouring gas, rather than by starlight itself. When matter falls toward a black hole, it is heated to unimaginable temperatures, shining brilliantly. From afar, this glow can be mistaken for the light of stars. If this interpretation is correct, then primordial black holes were feeding on the universe's earliest gas clouds, swelling in size while simultaneously casting light across the infant cosmos. These monsters would have lurked quietly for hundreds of millions of years, waiting for the universe to mature enough to supply them with fuel. The implications are staggering. Such black holes could explain how supermassive giants grew so quickly in the early universe. They had a colossal head start, hundreds of millions of years before galaxies even took shape. But this idea also opens a darker possibility. If primordial black holes were common, here, gravity should pull it to one side or the other, yet it hangs suspended like a cosmic judge between two rivals. Astronomers Peter van Dokkum and Gabriel Brammer suggest this may be the first evidence of direct collapse black hole formation. Instead of arising from the death of massive stars, this black hole could have formed when immense gas streams, created by the galaxy's crash, collapsed straight into a black hole without ever forming stars. Picture a cosmic avalanche of gas so heavy that it caves in on itself, creating its own gravitational prison. This process may explain one of Webb's greatest puzzles: the detection of supermassive black holes that are inexplicably huge given their age. If some black holes are born directly from collapsing gas clouds rather than slowly growing from stellar remnants, They could achieve monstrous sizes far more rapidly than current models allow. The Infinity Galaxy now acts as a living laboratory for studying this exotic process. Observations show the central black hole actively feeding on the streams of gas bridging the two galaxies, swelling in size as the collision unfolds. Radio data confirms intense bursts of energy exactly where the black hole should be, proving it is consuming matter in real time. But perhaps the most unsettling implication lies not in what astronomers see today, but in what this suggests about the young universe. If direct collapse black holes were common in its earliest days, then the cosmos must have endured an era of staggering violence, leaving behind objects stranger than wandering black holes. Among these remnants are hundreds of rogue planets, adrift without stars to call home. Webb has already spotted more than 500 such free-floating worlds in the Orion Nebula, each roughly the size of Jupiter. Flung away from their birth systems, they now roam the cold depths of interstellar space. Even more astonishing, many of these worlds travel in pairs, locked together in a mutual orbit that can span from 25 to 400 times the Earth-Sun distance. Scientists have given them a name: Jupiter mass binary objects, or jumbos. Their existence challenges every model of planet system. Evidence points to the signals being tied to the paired nature of these wandering giants. When two massive planets orbit one another, their gravitational pull creates complex magnetic interactions and electrical currents. It's as though the planets are grinding against the invisible fabric of space, generating energy through a kind of cosmic friction on a colossal scale. These binary wanderers function almost like natural dynamos, colossal generators powered by their endless orbital dance. Yet, the radio emissions refuse to fit into any simple pattern. Each pair seems to possess its own unique electromagnetic identity. Some emit steady, continuous streams of radiation, while others flare unpredictably, throwing out sudden bursts that obey no recognizable rhythm. The possibility that these orphaned planets can act as powerful radio sources raises unsettling questions. If their magnetic fields truly exceed those of anything found in our solar system, the space weather they produce could influence nearby star systems in ways we can't yet predict. But the greater implication lies in the sheer numbers. If hundreds of these planetary pairs are drifting in just one nebula, then across the Milky Way there could be countless millions, even billions, of such rogue companions. Each represents a shattered solar system where gravitational chaos flung planets into exile. They are cosmic castaways, wandering in eternal darkness, severed from the warmth of stars. Their only lifelines are the faint heat of radioactive decay within their cores, and the tidal stresses generated as they orbit their silent partners. Still, as strange as these planetary outcasts may be, Webb has uncovered something even more jarring: worlds forming in a way that breaks the most fundamental rules of planetary science. In the stellar nursery known as NGC 6357, astronomers discovered a young system with a planet-forming disk that defies expectation. Where rocky, Earth-like planets should be assembling, the disk is almost completely devoid of water. Instead, it is rich in carbon dioxide. This discovery upends the foundational idea that rocky planets require water, ice, and silicate minerals in abundance during their birth. Water is one of the universe's most common molecules, and every model of planetary development has assumed it must dominate these regions around infant stars. Its presence is thought to be essential for shaping geology, atmospheres, and eventually, the possibility of life. Yet, in this system, known as XUE-10, Webb's near-infrared spectrograph revealed an inner disk where water barely registers, replaced almost entirely by carbon dioxide. This suggests that any planets forming here would emerge under chemical conditions utterly alien to our solar system. They might develop into worlds with no parallel in our experience. Two possible explanations exist, and both raise troubling questions. The first proposes that intense ultraviolet radiation, either from the young star itself or from massive neighbors in the star-forming region, has blasted apart water molecules, driving hydrogen away and leaving oxygen to bond with carbon. The second theory is even more unsettling. The dominance of carbon dioxide in this system may come from unusual conditions within the dust grains that make up the disk itself. Unlike the water ice-coated particles typically seen in young planetary nurseries, these grains could instead be sheathed in carbon dioxide, shaped by the specific and extreme environment surrounding the infant star. Whichever explanation proves correct, both point to the same unsettling truth. Planetary formation is far less uniform than once believed. If ultraviolet radiation is capable of stripping away water from planet-forming disks, then countless potential Earth-like worlds across the galaxy may never acquire the chemical foundations necessary for life. Instead, they might emerge dry and barren, their chemistry dominated by carbon dioxide rather than the water so essential to life as we know it. This discovery forces astronomers to reconsider the diversity of planetary systems across the cosmos. If the building blocks can vary so dramatically, then entire classes of planets may exist with geologies and atmospheres operating under rules alien to anything we've encountered before. The XUE-10 system, in this sense, becomes a rare natural laboratory, a chance to study how planets take shape when the most basic ingredients are fundamentally different from those that shaped our solar system. Yet, the chemical oddities uncovered by Webb were only the beginning. The telescope soon turned its gaze toward a world so extreme, so hostile, that it pushed the very definition of what a planetary atmosphere can be. This scorched giant orbits its star at such a close distance that its year lasts just 18 hours. Known as 55 Cancri E, it is a world locked in perpetual imbalance. One hemisphere faces its star without pause, its surface glowing with the heat of molten metal, while the other side is cloaked in unending darkness. On the day side, temperatures soar beyond 4,000 degrees Fahrenheit, hot enough to vaporize nearly every substance we know. By the standard rules of planetary physics, such an inferno should have stripped the planet bare of any atmosphere billions of years ago. And yet, Webb's instruments revealed something astonishing. Against all odds, this hell planet is not airless. Instead, it possesses a thick atmosphere, dominated by carbon monoxide and carbon dioxide, gases that should not exist in such conditions. This conclusion came from precision temperature readings using Webb's mid-infrared instrument. When scientists measured the heat radiating from the planet's star-facing side, they found it unexpectedly cooler than it should have been. Something was redistributing the energy across the planet's surface. The only explanation: a dense atmosphere strong enough to carry heat from the blazing day side into the frozen night. The result is one of the most violent weather systems ever imagined. Supersonic winds, thousands of miles per hour, sweep across the planet, carrying with them vaporized rock and metal. On the night side, those vapors condense, falling back to the surface as rain composed of molten minerals. The temperature difference between the two hemispheres should exceed 3,000 degrees, but atmospheric convection smooths it out, creating storms no Earth-based laboratory could ever reproduce. What makes this atmosphere even more impossible is the question of its origin. It cannot be left over from the planet's formation. Stellar winds from its star would have scoured away any primordial gases long ago. Instead of holding on to a primordial atmosphere, scientists now believe this world is sustained by a secondary one, constantly replenished from within. Imagine a planet where the crust itself simmers and boils. The intense more than 130,000 miles per hour, fast enough to cross the United States in under 2 minutes. Atlas moves with a trajectory far too straight and flat to belong to our solar system. It obeys the gravity of the galaxy itself, treating our sun as just another passing light. What makes this discovery unsettling is not only its age, but what it represents. 3I Atlas is a messenger from an era when the Milky Way was chaotic, violent, and chemically primitive. 7 billion years ago, stars formed rapidly, heavy elements were scarce, and the chemistry that builds planets was still young. This comet was born around a star that has long since died, perhaps torn apart in a cataclysmic supernova, leaving behind this wandering shard of its system. For billions of years, it has drifted alone, a frozen time capsule carrying signatures of an age lost to history. And if we have found one such object, how many more are silently passing through our skies unseen? Atlas is only the third confirmed interstellar object ever discovered, but statistical models suggest there could be dozens, perhaps hundreds, crossing through our neighborhood at any given time. Each one is an artifact of a destroyed world, a fragment of a vanished star system, carrying chemical records that no other object can provide. But perhaps most haunting is the mirror this discovery holds up to us. One day, when the sun dies, fragments of our own world may be cast out into interstellar space, to wander as relics in someone else's night sky. Yet even this ancient visitor was not the strangest thing Webb uncovered. In its deepest surveys of the early universe, the telescope found hundreds of mysterious objects glowing in the dark. Objects unlike anything scientists expected, tiny red points scattered across the cosmos. Too bright, too strange, too unexplainable. These strange objects exist at an era when the universe was less than 1 billion years old. Yet their brightness is astonishing. They radiate extraordinary amounts of energy through mechanisms no one fully understands, combining traits that don't resemble galaxies caught in explosive bursts of star formation. The most unsettling possibility is that they represent an entirely new stage of cosmic growth, one we've never seen before. The first billion years after the Big Bang were unlike anything that followed. Matter was denser, dark matter interacted more frequently, and the great cosmic web was only beginning to take shape. In such conditions, perhaps exotic objects could form that are no longer possible in the modern universe. Certain red dots also show signs of extreme energy, producing X-rays, ultraviolet radiation, and infrared light in violent patterns that stretch the limits of known physics. Even more surprising, they aren't found in neat clusters where galaxies were expected to gather, but appear scattered at random, suggesting they might reveal something fundamental about the early cosmos itself. Researcher Bang Jiang's son, who led much of the analysis, stresses that even if just a fraction of these objects are real, our theories of how galaxies first arose will need rewriting. And given the sheer number Webb has uncovered, it's clear that our picture of the infant universe is deeply incomplete. These crimson anomalies may be the greatest puzzle in cosmology revealed so far, yet they are only the beginning. Because when Webb turned its gaze to the grand structure of the universe itself, it revealed something even more astonishing. Galaxies stretched across immense distances seem to rotate in unison, hinting that the entire cosmos may have been born with a built-in spin. This revelation came from the study of 263 galaxies observed in Webb's deep extragalactic survey, and it may be the most mind-bending discovery of all. When astronomers studied the spin and alignment of faraway galaxies, They uncovered something that standard cosmology says shouldn't happen. Star systems separated by millions of light years, too far apart to ever influence one another, were rotating in the same direction. Imagine discovering that every windmill across an entire continent turns identically, even though no wind could coordinate their motion. That's what Webb revealed. Galaxies locked in a synchronized cosmic dance across impossible distances. Leo Shamir, the researcher leading the analysis, offered two explanations, both unsettling. The first possibility is that the universe itself was born with spin. If the Big Bang carried angular momentum, it might have imprinted a preferred direction of rotation on cosmic structures ever since. This idea resonates with a radical proposal known as black hole cosmology, which suggests our universe could lie inside the event horizon of a much larger black hole. In that case, the spin of the parent black hole could echo across the fabric of our cosmos. The second explanation is equally troubling. If the universe didn't begin rotating, then these synchronized spins mean our current theories of cosmic growth are missing something enormous. Some unknown force or field must be shaping galaxies on scales larger than scientists have ever considered. The implications are staggering. A rotating universe would behave very differently than the static one described by conventional models. Space and time themselves might have preferred directions, bending the rules of physics. Even the mysterious push of dark energy could behave unevenly, driving cosmic expansion faster in some directions than in others, perhaps explaining anomalies in Webb's data. And if our universe is truly spinning within a greater structure, it may mean we inhabit just one realm in a far larger multiverse, where entire universes swirl like galaxies in some higher dimensional space. These coordinated galactic rotations shake the very foundations of cosmology. But Webb's revelations didn't stop there. Its next observation uncovered something even more astonishing: the birth of a black hole through a process long thought impossible. Deep in the cosmos lies a system dubbed the Infinity Galaxy, where two galaxies are colliding in a dramatic merger. Suspended between them, in a region where no black hole should exist, sits a supermassive one forming not through dying stars, but through the direct collapse of gas itself. Instead of stellar explosions leaving behind remnants that slowly grow, this black hole emerged as a sudden gravitational avalanche, collapsing straight from vast rivers of hydrogen gas. Astronomers Pieter Vanhem and Gabriel Brahma spotted the unusual figure-8 shape of the system and followed up with deeper observations. To their astonishment, radio signals revealed a massive black hole, exactly where theory said one shouldn't survive, floating between the colliding galactic cores. The process, unlike anything previously confirmed, skips the normal step of star formation. The galaxy's crash funneled enormous amounts of gas into dense streams, which collapsed instantly into a black hole, millions of times the mass of our Sun. By bypassing stellar evolution, these direct collapse black holes gain a massive head start, explaining why Webb sees gigantic black holes less than 1 billion years after the Big Bang, far earlier than standard theory allows. The Infinity Galaxy provides a rare real-time view of this violent creation. The black hole is actively devouring gas, growing larger even as astronomers observe it. Such discoveries suggest that black holes may not be secondary products of galaxy growth, but central engines driving the organization of matter on cosmic scales. Yet, this revelation also paints a darker picture of the early universe. If direct collapse was common, then galaxy formation was not a slow, gentle process, but one filled with sudden catastrophes capable of birthing the most extreme objects in existence. The Infinity Galaxy shows that nature has shortcuts to creating monsters, methods more brutal and efficient than we ever imagined. And yet, even this violent process wasn't the limit of Webb's discoveries. The telescope was about to uncover black holes feeding in ways more extreme than any scientist had ever predicted. The telescope's next revelation was a cosmic predator feeding in a way that should not be possible. In the young universe, astronomers uncovered a black hole devouring material at a rate 40 times greater than physics says it should allow. Its appetite is so extreme that it threatens to overturn everything we thought we knew about how these monsters grow. This object, labeled ELID 568, was first buried among thousands of X-ray sources glowing been teeming with light. Astronomers have begun to call them sleeping beauty galaxies. These are enormous star systems that, against every expectation, stopped forming new stars in what should have been their most active era. Containing stellar masses rivaling our Milky Way, they exist as vast collections of stars frozen in time, their growth abruptly halted without warning. The puzzle emerged when scientists examined galaxies that formed between 600 million and 6 billion years after the Big Bang. This was an age when the universe was rich in gas, dark matter, and all the ingredients for rapid stellar creation. Most galaxies from this era are dazzling with newborn stars, consuming their gas supplies at reckless speed. Yet among them, Webb found systems as massive as great cities where construction suddenly ceased. The nickname Sleeping Beauty captures their paradox. Like the fairy tale princess who drifted into enchanted slumber at the height of her youth, these galaxies shut down in their prime, leaving astronomers to wonder what spell silenced them. Theories have been put forward, none without consequence for our understanding of cosmic history. One possibility is that the supermassive black holes at their centers became too powerful, pouring out so much energy that the surrounding gas was heated beyond the threshold where stars could form. Known as active galactic nucleus feedback, this process can halt starbirth across entire galaxies, locking them into a state of quiet that can last billions of years. The explanation for these so-called sleeping beauty galaxies isn't straightforward. One theory blames the energy released by the supermassive black holes at their centers, but the timing doesn't add up. The galaxies appear to have stopped producing stars long before their black holes became active enough to shut down starbirth on such a large scale. Something else must have forced them into dormancy. Another idea is that these galaxies burn through their fuel at astonishing speed, consuming nearly all their gas during an early burst of star formation. If true, it would mean that young galaxies were able to create stars far more efficiently interstellar space, carrying the most bizarre atmosphere ever observed. Catalogued as S0136P0933, this lonely world does not orbit any star, glowing faintly from its own internal heat. Yet its skies are layered with metallic weather, unlike anything found in our solar system. At its lower altitudes, thick clouds of vaporized iron condense into storms that literally rain liquid metal. Above this layer lies another, composed of magnesium-rich crystals, minerals common in meteorites, now forming alien clouds. The planet's atmosphere resembles a cosmic layer cake, each stratum producing different storms and dynamics. Webb's infrared instruments revealed that these cloud layers are patchy and restless, constantly shifting under the influence of the planet's rotation and hidden heat. Even more extraordinary, the upper atmosphere flares with searing hotspots powered by radio auroras. These auroras function like Earth's northern lights, but at energy levels that would obliterate any known form of life. Such intense auroras point to an unimaginably strong magnetic field, far greater than anything in our solar system. This magnetic shield funnels charged particles into the upper atmosphere, heating it to temperatures higher than those in the metallic clouds below. According to Alison McCarthy, the lead researcher, this is the first direct evidence of mechanisms once thought to be only theoretical. The combination of iron rain, magnesium clouds, and lethal auroras paints a picture of weather systems operating by principles never before witnessed. That such complexity exists on a planet drifting alone through the darkness suggests that rogue worlds may host far richer and stranger atmospheric processes than we ever imagined. If one wandering planet can produce storms of molten iron, there could be millions of others scattered across the galaxy, each with unique and alien climates. And just as astronomers were grappling with the idea of metallic rain worlds, another cosmic oddity appeared. A distant galaxy shaped like a vast, glowing owl, stretching its luminous wings across the void. Its tentacle-like structures hint at ancient collisions and interactions more violent than anything we've seen before. Another reminder that the early universe was alive with chaos. When the James Webb Space Telescope first captured the galaxy nicknamed the Cosmic Owl, astronomers were charmed by its playful resemblance to a bird's face. Its luminous core looked like two glowing eyes, while the gas and dust surrounding it created feather-like patterns. But closer studies showed that behind the light-hearted name was something far more unsettling. This galaxy is part of a rare class known as jellyfish galaxies. Instead of moving peacefully through space, it trails vast tentacles of stars and gas, evidence of a brutal process tearing it apart. As the galaxy plows through the scorching gas that fills galaxy clusters, it experiences what scientists call ram pressure stripping. The surrounding medium acts like a powerful cosmic headwind, peeling away huge sections of the galaxy's structure. Imagine riding in a speeding convertible, only to watch loose cargo fly out the back. Except here, entire stellar systems are being blown into space. Webb's infrared vision revealed the true violence at play. The galaxy's tentacles stretch for hundreds of thousands of light years, containing billions of displaced stars. These stellar refugees are now stranded far from their origin, slowly dispersing into the emptiness of intergalactic space. More striking still, the stripping process tells astronomers that the galaxy is moving through an environment far denser and hotter than once believed. Instead of drifting serenely through emptiness, galaxies are battling against turbulent cosmic seas, capable of tearing them apart. And yet, destruction comes with creation. As gas is stripped and compressed, new stars are born within the tentacles themselves. Webb detected clusters glowing bright with the blue light of young stars, nurseries forming in isolation, disconnected from the galaxy that once gave them their raw material. The cosmic owl is both dying and giving birth at the same time. These jellyfish structures are now being found across Webb's deepest surveys, suggesting that galactic stripping and cannibalism are far more common than earlier models predicted. The universe may be filled with stellar wanderers, cosmic refugees of gas and stars ripped from their homes, left adrift in the void. But even this large-scale violence pales beside the discoveries taking place inside individual star systems. Webb has uncovered newborn stars producing heavy elements that shouldn't exist so early in cosmic history. Young stellar nurseries are generating oxygen, carbon, and nitrogen in abundances that seem impossible for their age. This mystery challenges our understanding of how the universe's chemical complexity emerged. Astronomers use the word metallicity to describe elements heavier than hydrogen and helium. In the universe's earliest days, only those two existed in abundance. Every heavier element, carbon, oxygen, iron, even gold, had to be forged in the nuclear hearts of massive stars, then spread through the cosmos when those stars exploded as supernovas. By theory, this is a slow process. The very first stars, called Population 3, would have been made of almost pure hydrogen and helium. Only after they lived and died could their enriched remains seed the next generation of stars. For Webb to find young systems already rich in heavy elements means something is happening that our current models cannot explain. The cosmic cycle of chemical enrichment normally takes billions of years, as one generation of stars lives, dies, and scatters its heavy elements to seed the next. Yet the James Webb Space Telescope has uncovered star systems that appear to have leapt ahead in this process. Entire galaxies, less than 1 billion years old, are already rich in oxygen, carbon, and nitrogen. Levels of complexity that should have required several rounds of stellar birth and death. One of the most astonishing cases is galaxy JWST 131, observed just 330 million years after the Big Bang. Spectroscopic data revealed clear hydrogen emission lines alongside signatures of heavier elements, as though the galaxy had already undergone multiple stages of evolution, despite existing during the universe's infancy. This discovery forces scientists to confront an unsettling possibility. Either the very first stars were far more massive and short-lived than expected, cosmic giants burning through their fuel in mere millions of years before, exploding in titanic hypernovas, or some unknown process was enriching space with complex patterns far more intricate than expected. Instead of simple uniform fields, these structures resemble neural networks, with nodes, branching connections, and hierarchical layers echoing the architecture of the human brain. So striking is the similarity that researchers have begun applying the same mathematical tools used to study brain connectivity to this cosmic magnetism. The implication is profound. The universe developed a hidden layer of organizational complexity far earlier than science had imagined. Standard models hold that magnetic fields arise gradually, amplified by stellar winds and supernovae over billions of years. But these primordial fields predate galaxies themselves, suggesting they shaped the collapse of gas into the first stars, influenced stellar masses, and altered chemical evolution in ways still unknown. Even more unsettling, the networks appear to change over time, forming and breaking connections like a vast cosmic circuitry. Instead of a silent, empty void, the early universe may have operated more like a dynamic system of information processing, its magnetic skeleton weaving order into chaos long before galaxies took shape. Webb has detected vast magnetic storms sweeping across entire galaxy clusters, events powerful enough to alter star formation and influence the growth of galaxies across immense stretches of space. These findings reach deep into our understanding of dark matter and dark energy, since magnetic forces interact with charged particles in ways that can reshape how matter gathers together on cosmic scales. If magnetism in the early universe was stronger and more intricate than current theories allow, it could help explain the puzzling gaps in our models of cosmic structure. The discovery of magnetic networks resembling brain-like connections challenges our assumptions about how complexity arises in the universe. If such organized patterns were already present in the earliest epochs, it suggests the cosmos carries within it an innate drive toward complexity that we have only begun to recognize. These ancient fields might even hint that the universe functions with properties comparable to living systems, capable of processing information and self-organizing in ways we don't yet understand. Meanwhile, at the heart of our own galaxy, a different mystery is unfolding. Sagittarius behavior suggests Sagittarius A is far more active than once assumed, a creature of continuous, unpredictable violence rather than a dormant giant. What makes it deeply unsettling is that these eruptions occur at the very edge of spacetime, where gravity is so extreme that our current laws of physics begin to fail. The randomness hints that quantum effects might play a role in the flow of matter and energy around black holes, blurring the boundary between classical and quantum realms. Some researchers even suggest it raises questions about whether information truly vanishes inside black holes, challenging one of the deepest principles in physics. Beyond our galaxy, Webb's lens has revealed even darker violence. Invisible forces are tearing apart galaxies and rewriting the architecture of the cosmos. Dark matter, the unseen mass that makes up the bulk of the universe, appears to engage in catastrophic interactions powerful enough to shred galaxies and rearrange structures across millions of light years. The evidence comes from Webb's imaging of galaxy clusters, immense cosmic cities bound by dark matter's gravity. When these clusters collide, they release energies rivaling billions of supernovae, yet the devastation spreads far beyond the visible collisions. Galaxies millions of light years from the impact zones show signs of distortion and disruption, forces that cannot be explained without invoking dark matter's hidden hand. Webb has traced enormous streams of stars and gas linking galaxies together, like cosmic bridges, the remnants of systems ripped apart by invisible gravitational tides. Unlike normal matter, which produces visible fireworks during collisions, dark matter leaves no light, no heat, no signal, only silent scars across the universe. The only trace we have of these devastating cosmic events comes from the gravitational pull they exert on the matter we can actually see. With its powerful infrared vision, the Webb telescope has been able to uncover the hidden scale of this dark destruction. Faint stellar streams and long tidal trails stretch across millions of light years, weaving enormous webs of disrupted matter that older telescopes could never detect. Each faint trail marks the ruins of a galaxy, torn apart wholly or in part by the influence of dark matter. This reveals something profound. Dark matter may not be just a silent scaffolding holding galaxies together. Instead, it actively reshapes the universe. These violent interactions can expel galaxies from their homes, strip away their reserves of gas, and scatter their stars into the emptiness of intergalactic space. Simulations of dark matter behavior suggest that these brutal encounters are not rare, but central to the universe's evolution. Collisions and gravitational exchanges between dark matter particles might generate shockwaves that ripple through the cosmic web, influencing how galaxies form and evolve across incomprehensible distances. The most unsettling aspect is what these hidden upheavals imply about dark matter itself. If it can unleash such catastrophic energy, then it must possess properties far beyond the simple pull of gravity. Some scientists suspect that dark matter particles might undergo transformations, or even interact through forces still undiscovered. This revelation forces us to rethink how galaxies grow and change. If they are constantly battered, reformed and disrupted by dark matter's invisible hand, then the universe is not the calm and orderly system we once imagined. It is far more turbulent and unpredictable. These unseen catastrophes, though invisible to the eye, are a fundamental force shaping cosmic history, leaving only their wreckage as testimony. And the strangeness does not stop there. Webb has also observed a distant galaxy whose gravity bends space-time so powerfully that it appears in multiple places at once. The phenomenon, known as strong gravitational lensing, occurs when an object is so massive that it warps space-time like a giant lens, distorting light from galaxies behind it. In this case, the galaxy's pull is so extreme that Webb detected at least 4 separate images of the same galaxy behind it, each image magnified differently and frozen at a different moment in the galaxy's history. Light traveling along these warped paths takes different times to arrive, meaning we are essentially watching the same galaxy story unfold at multiple points in time, simultaneously. In one image, the galaxy looks as it did 800 million years ago. In another, as it was 1 billion years ago. This lensing galaxy has become a natural time machine, displaying stellar evolution across vast epochs. But the discovery is troubling. To create such an intense warping of space-time, the galaxy must contain concentrations of dark matter far denser than our models allow. Instead of the smooth halos predicted by cosmology, Webb has revealed clumps and gaps, suggesting dark matter organizes itself in ways we do not yet understand. Even more disturbing, these extreme distortions push general relativity into regimes where it may break down, hinting that quantum gravitational effects might already be influencing the structure of space-time. If such environments exist here, they may be common elsewhere in the universe, places where reality itself is bent beyond recognition. Webb has also revealed scenes of cosmic cannibalism on a stellar scale. Throughout the universe, stars in binary systems are consuming their companions in frenzied feeding events. The process begins when 2 stars orbit so closely that the larger one strips material from the smaller. This stolen matter spirals inward, forming blazing accretion disks that eventually trigger catastrophic explosions. In some cases, white dwarfs, stellar corpses with the mass of a sun compressed into a sphere the size of Earth, feed on their neighbors until they explode as supernovas, briefly outshining entire galaxies. In even more violent cases, neutron stars and black holes devour their companions, unleashing kilonova explosions that forge precious elements like gold and platinum, while releasing gamma-ray bursts that blaze across billions of light-years. Webb's infrared eyes have tracked this entire process, from the first trickle of stolen gas to the final detonation that scatters heavy elements into space. Disturbingly, these events appear to be common, perhaps even essential to cosmic chemical evolution. Many of the ingredients necessary for planets and life may come from these violent feeding frenzies. The telescope has also observed failed cannibalism events, where stars begin the process, but are interrupted before destruction, leaving behind bizarre stellar remnants unlike anything near us. These findings force astronomers to reconsider the life cycles of stars. Rather than dying peacefully, many end in explosive acts of cosmic violence. But the most unsettling revelation may be about space-time itself. Webb has found mounting evidence that reality is not as solid as we imagine. Gravitational anomalies, unexplained radiation, and irregular structures suggest that the smooth space-time described by Einstein may fray under extreme cosmic conditions. Near colossal black holes, within galaxy clusters, and around massive structures, Webb has seen deviations too persistent to ignore. These effects may be signs of quantum foam, the turbulent, chaotic fabric predicted by quantum mechanics. bubbling up from the smallest scales to cosmic levels. Strange radiation near black holes, unexpected heating in galaxy clusters, and gravitational patterns that defy explanation all point toward cracks in reality. Some evidence even hints at cosmic strings, possible scars in spacetime left from the universe's birth. One-dimensional, defects where the very fabric of reality is torn. If they exist, they are permanent flaws written into the structure of the cosmos itself. Most astonishing are signs of vacuum decay, where regions of space may have dropped into lower energy states, releasing vast amounts of energy in the process. Such transitions would mean that even the vacuum of space is unstable, a terrifying thought for the stability of the universe itself. All of this leads to one radical possibility. Our universe may be the interior of a black hole inside a larger universe. The strange galactic rotations, the contradictions in cosmic expansion, and the discovery of primordial black holes all fit this model. What we think of as the Big Bang may have been the moment our universe crossed the event horizon of a larger black hole, giving us the illusion of expansion. From outside, we would simply be falling forever toward a singularity. If true, this means every galaxy, star, and planet we see is trapped inside a cosmic prison, cut off from any larger reality, and each black hole in our own universe might contain entire universes within them, creating an infinite nesting of realities. Webb's discoveries have not only rewritten astronomy, they have redefined what it means to exist. We no longer live in a predictable, orderly cosmos, but in a violent, unstable, and deeply alien reality. Galaxies appear faster than physics allows. Black holes roam freely through the dark, and even space-time itself may collapse under pressure. Yet, within this strangeness lies possibility. If the universe can create impossible galaxies and naked black holes, it may also create forms of life and intelligence we cannot yet imagine. Webb has shown us that we are still children in a vast, incomprehensible cosmos, surrounded by mysteries that both terrify and inspire. Reality does not exist to be simple or comforting. It follows its own hidden laws. Our survival depends on adapting to them, no matter how strange or unsettling they may be. The universe Webb reveals is chaotic, violent, and full of secrets, but it is the only reality we have. Understanding it is our best hope for the future.